Good morning, everyone. Today is all about solving one-step equations. So what you can do while you're watching this video is you can download the note sheet from Schoology and you can take notes along with me as I go through this. So today is all about solving equations, and it's all about getting a single variable by itself. We're going to have a bunch of other numbers that are in the way, and what we need to do is just get rid of them. And what we need to be really good at is determining what opposite operations are. And we have three examples right here. The opposite of adding is subtracting. The opposite of multiplying is dividing. And I'm using the symbols there. And the opposite of a squared term, if you don't remember what a squared term is anytime we take a number or a variable and we raise it to the second power, so x squared. The opposite of a squared term is the square root. Okay, let's look at some examples, and we're going to start with word problems, which I know we're not particularly fond of, but we're going to start with those because they help us understand how this works. So the first example, it says Adam the adder is saving up for a car. He currently has $1,800 saved up. The car he wants costs $2,500. How much money does he need to save in order to afford the car? Okay, so let's start with what we know. We know that Adam has $1,800, and we know the car he wants costs $2,500. Okay, and we know that he needs to save a certain amount of money, which means he needs to add to that $1,800 a certain amount of money, so he has $2,500. Now, in the real world, all we'd have to do is look at this and say, well, if he has $1,800 and the car is $2,500, all we have to do is subtract $1,800 from $2,500, and that's going to get us our answer. Well, it's the same thing when we set it up in the form of an equation. We're going to subtract $1,800. In this case, we do it from both sides of the equation to keep it in balance. And when we do that, the 1800s cancel each other out on the left-hand side, and we're left with x is equal to $700. So he needs to save $700 in order to buy the car he wants. Okay, let's look at another one. In the next problem, we have Sierra the subtractor. She ran out of storage on her iPad, so she decided to delete some videos to clear out space. She deleted 240 videos and now has 650 remaining. How many videos did she have at the start? Okay, so what we need to think about is she started with some number of videos, and since we don't know, we can call that x. And we know that she deleted videos, and when it says deleted, that means subtract. So she subtracted 240 videos. And as a result, she ended up with 650 videos. Okay, so now in the real world, we could just look at this and say, well, she deleted 240. She now has 650. So all I have to do is add those two numbers together to figure out how many videos she started with. Well, it's the same thing when we're solving an equation, because we're just going to add 240 to both sides of the equation. And when we do that, the 240 cancels each other out. So we're left with x is equal to 890 videos. Okay, so in both of these examples, what I want you to notice is we did the opposite of what we saw. So in the first example, we saw $1,800, so we subtracted $1,800. In the second example, we saw subtracting 240 videos, or deleting, and so we added 240 videos to both sides. So we did the opposite of what we saw. All right, let's look at another example. Let's look at Morgan the multiplier. Morgan the multiplier worked a summer job landscaping. They are getting paid $25 per hour, and at the end of the day earned $175. How many hours did they work? All right, anytime we see $25 per hour, we know that that's going to be multiplication. because per stands for multiplication. So we know that Morgan got paid $25 times a certain number of hours. We don't know how many hours, so we're just going to say 25x. And we know at the end of the day they earned $175. Okay, so how many hours did they work? Well, what I see here is multiplication because 25 times x. So what I want to do is I want to do division. So when I divide, the 25 cancels, so I'm left with x. And on the right-hand side, 175 divided by 25 is 7. So that means Morgan worked for 7 hours. Okay, one more. DeAndre, the divider, is a sweet grandmother. She gave each of her 12 grandchildren the same amount of money for their birthdays this past year. Each grandchild received $40. How much total money did DeAndre give out? Well, we have to think about that. So DeAndre gave a big chunk of money to 12 different people. So if she gave a big chunk of money to 12 different people, we know that that money, we don't know how much it is, so we're going to call it X. And if she gave it to 12 different people, that means she divided it into 12 pieces. So we do X divided by 12, and we know that that amount that she gave each person was $40. Okay, so I see division on the left-hand side. So what I need to do is multiplication. So I'm going to multiply by 12, and I put it in parentheses because there's a lot of stuff going on here. And I multiply it by 12 on this side as well. So on the left-hand side, the 12s just cancel each other out. So I'm left with X is equal to $480. Okay, so she started with $480 and then divided it by 12, so each grandchild received $40. Okay, so these are word problems, and hopefully you can relate to those, and it'll help you understand how to solve one-step problems. Okay, so here's some more examples though, and these examples are just regular old problems, and we don't have any word problems to go with them. So what we have to do is we just have to look for what we see and do the opposite of what we see. So in this first example, we have x plus 8 equals 32. So I see plus 8, so I want to subtract 8 from both sides. So I'm going to subtract 8 from both sides. And when I do, the 8s cancel each other out. So I'm left with x is equal to 24. Okay, let's go down. In this next example, we have x minus 10 equals negative 20. So we're throwing some negative numbers into this one. And so I see minus 10. So I'm going to do the opposite of minus 10. So I'm going to add 10 to both sides. And when I add 10 on the left-hand side, it just cancels. So I'm left with x is equal to negative 10. Oops, it's not working. Okay, so this is one that maybe you should grab a calculator and just punch that into your calculator so you can see what happens. Another thing you could do is just think about a number line. And if we look at negative 20 on that number line, and we have 0 over here, and anytime we add 10, that means we're moving to the right. So we're moving to the right 10, so that's going to take us to negative 10. So that's why that answer is negative 10. Okay, let's keep going. All right, let's look at this next problem. In the next problem, we have 5x equals 28. So I see multiplication, so I'm going to divide on both sides. And when I divide on both sides, the 5 cancels each other out. And I'm left with x is equal to, well, this one, 5 doesn't go into 28 nice and neat. So if you grab a calculator, 28 divided by 5 is 5.6. Okay, let's go down. Try the next one. Now in this next one, the x is on the right-hand side. And that's okay. Sometimes we're going to see that. And I see a plus sign there, but I don't want to really look at that plus sign. What I want to look at is that 12 and determine if that 12 is positive or negative. And I can look at that and see it's positive. And positive means addition. So I want to do the opposite of addition. So I'm going to subtract 12 from both sides. And when I do, the 12s cancel. I have an x on the right-hand side, and I have a 28 on the right-hand side. I mean left-hand side. All right, here we go. The next one. So in this one, we have x divided by 7 is equal to 3. And if you remember from DeAndre, the sweet grandmother, we multiplied when we saw division. So we're going to multiply here by 7 on both sides. And when we multiply by 7, the 7's cancel each other out. So we're left with x is equal to 21. Okay, one more. Now this one has negatives and it has the x on the right-hand side. So in this case, I see multiplication, so it's a negative 2 times x. So I see multiplication, so I'm going to divide by negative 2. And when we divide by a negative, so on the right-hand side, the whole thing just cancels each other out. But on the left-hand side, when we divide a negative by a negative, the negatives cancel each other out. So we know our answer is going to be positive. So I'm going to end up with x on the right-hand side and 25 on the left-hand side. Okay, last one. Wait a minute, no, these are ones you get to do. All right, so what I want you to do now is pause the video and take some time to work through these 6 problems on your own. So now that you've had a chance to work on those, let's look at one last thing before I send you off on your own. In this example, we have a grid. It shows a square that has a total of 196 small squares inside. Without counting, we want to figure out what is the length of each side. All right, so we want to know what the side length is, but we don't want to count. So I'm going to put S's on all the sides for the side length. And we know with a square, they're all exactly the same length. In this case, we're given some information about the square. It has a total of 196 small squares inside. Well, that's area. And we know the area of a square is just the side squared. Okay, so if 196 is area, that means we can replace the area with 196, and it equals s squared. And then if you remember from the very beginning when we were talking about opposites, the opposite of a squared term is square root. So we're going to take the square root of both sides, and when we do, we have s on the right-hand side, and the square root of 196 is 14. So that means there are 14 squares on each side. And we can come over here and count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're correct. All right, I want you to try these last 3 on your own. When you are done with this assignment, save it as a PDF and upload it to Schoology so I can grade it for you.